if you have come here, then God help you. What I can recommend is this song. If you're taking a course, a computer science course, then you've sure as hell encountered Lisp. And here's a song about it. What was it? Ah, yes. The Land of Lisp. Big credit to this guy. He basically made a book. He sings about what's in the book. Yes, I watch Scooby-Doo. Yes, I like Metallica, stuff like that. Anyway, that's besides the point. The point is that I'm making this video for a couple of reasons. First off, if I forget for some reason how stuff works in Lisp, just to familiarize myself with how it works. So right now I'm gonna write a couple of algorithms about the Fibonacci sequence and what was it? The factorial sequence. Yes. And right now I'm gonna get started. Okay. So first off, we have define. Basically, we need to open up parentheses and name our function. I'm just gonna name it fib. You just need a single variable, which is x, and basically now we have a condition. Yes, and oh yeah. Basically, here's the tricky part, as people say. First up, you need to know if x is a 0 or a 1, and you need to return 0 or 1 if it's one of those values. So first up, you just gotta do this equal x 0 0 0. This is basically gonna return automatically. You don't need any return statement. If you're unlucky enough to say return whatever, then you're basically gonna be for a splitting headache. I've done it myself. Not a fact I'm proud of. So, okay. So, now, this is the best part. Basically, you do this, fib, which is x1 fib plus x2 I know the parentheses are confusing. Okay, let's format it well. I think we're gonna have a problem. Let's go at 8. Oh my god, it's see, there is a problem in here, and no, there's the freaking problem. Oh yeah, here's the problem. You need more parentheses. Like in the song, it says, if your code is not done, you need more parentheses. And sorry, this is from another thing. I'll explain it later. Anyway, take this fucker. Yes, I know I'm cursing, sorry. It's not polite, but given the fact that this is really frustrating, especially the parentheses, you will understand why that is so. Anyway, let's go with fib, and it works. Congratulations to us. Now, we're not out of the woods yet. If you want something else you can train on, you can probably want to search which given number, which Fibonacci number is bigger than a given number. I know, sounds confusing. That's what I passed in earlier. And basically, this is me training and showing people who don't know the algorithms themselves. Anyway, let's go. I'm just gonna go with a which I'm gonna change it up from what I did previously before recording this, and it's gonna be given and position, stuff like that. We have a const statement, and basically we have I'm just gonna do this. I'm gonna do this because I feel it's basically you just need to do a couple of things. Anyway, let's go. First, now in here we have I do admit I am forgetting. So yeah, we have to compare this to this Fibonacci position. So it's gonna be something like this, or this. I'm just gonna go with this, and it's gonna be Fibonacci position and given. And I know I just made that error, so it can be more clear to me. Okay, this is useless. We need only this. Yeah. I don't know if my style of programming in Lisp is good. I do admit it's not the best. And let's see. If there is a problem, then we just need to do this which nowhere. Now in here, let's see what we have. I think this is essential, since we are invoking a function. Sorry. And right now we're saying which, and we're going to pass in the parameter of given, and then we're going to pass in plus position, right? Okay. I don't know if this is it, but if it is, I don't know. I'm just gonna copy it for safety. Okay. Which I'll just say, just gonna give this, and it should output 7. And oh, yeah. It's gonna be position, and which is gonna be 10, 0. And this is basically your searching Fibonacci sequence. Okay, now is factorial. Factorial, I haven't practiced it that much, so basically it is something like from what I know, basically stuff like that. And basically you use the previous number, like you use this for this by multiplying it by this, stuff like that. And this is 6 because it's equal to 3 times 2 factorial, and on and on. Okay, this is just a reminder for me. I did make the algorithm perfectly the first time. This is basically my second time defining it, so yeah. Surf's up. Okay, let's go with fact, and we have an x, right? Okay, so we have a condition statement, and we have an open parentheses here. I don't know how much time I have. Oh my god, I do have a lot of time. Okay, I'm recording with Fraps. Yes, I know it's not the best software, but I didn't find it. I didn't want to search for another. Okay, let's see. We have this is it. Yes, this is my chair squeaking. I'm sorry. So we need to use this. Alright, okay. Now. Okay. We have to see if the condition is true. If it's true, if it's true, then okay. First off, we need to do this because we want to know if it's less or equal to 1 like x 1. We do this, and basically we return like 1. And basically right now what we're gonna do is type true, so this statement is always invoked if the first hasn't been invoked, and it's gonna be something like gonna be x. It's gonna be multiply x factorial x sorry, x1 that's it, and factorial, let's try factorial 4. And looks like the first time I was lucky. Right. So it's gonna be this. I probably forgot a parentheses. Let's see. Right now I'm not putting any thought to this. So yeah. Don't get upset at me. And we have this, and it's gonna be this, and basically that's it. So yeah. Okay. Basically these are the algorithms, and that's basically it. If you want to leave, you can leave. The rest of the video is going to be me explaining why do I have to put parentheses there. If you want to stay. So yeah, let's start with the Fibonacci sequence. So first off, we have an open parentheses, which the ending parentheses here. We have the name of the function and what argument it's gonna take. We have cons, which is condition, and here it's closing parentheses. Except we have this, which we check if it's 0 or 1 and return those values. And we have the last check, the last condition. Sorry. Anyway, we invoke this, and here what the results is going to be returned. That's why we have a parentheses here. Okay, and next up we have a plus. We open a parentheses because we need the value that's in here. So that's why we have a parentheses, and in here is the same, is no different. And after that we get the number, and basically return whatever the number it is. And yeah, next up we have the searching algorithm for the Fibonacci sequence. So first up we have given, then position, and in here basically the last one we always return position. The most tricky part is this, and in here we check the position, if the Fibonacci position is less than the given. If it is, we invoke this. And basically what it does is we invoke this function without any extra parentheses. We just need these parentheses because I think it's Lisp syntax. I don't know, I'm not that good with Lisp. I'm still learning it. I do admit, it is a hard language and a fun one at that. Even though then right now it's probably eating most of my nerves. Okay, so this and this is the closing parentheses, and here everything is fine, as you can see. And now we have the factorial sequence. Here's the right one, sorry. So first up, the function takes only one argument. Then we have a condition. We have two conditions. One is if x is less than or equal to 1. We return only 1, and then we have another statement which is always true, and we return from it x, which is the given number multiplied by the previous factorial that's going to be returned. And basically it works. Now, if you're asking me why did I do the same thing for the Fibonacci sequence, well, it's easy, because when we have 0 we need to return 0, and when we have 1 we need to return 1, and that's why there is a difference. And that's basically it. I hope you enjoy my video, and thank you for watching.